Alright, now let's just look into this particular question and see how can we solve that. So he want us to find out the volume of the solid, and we have learned this in our lessons that, for example, if we have this function f of x and we rotate that 160 degree in x along the x-axis, so we'll get a shape like this, which is a solid shape, and we can find out the volume of this particular shape, which is given by the formula which is given as pi times of f of x squared dx, and it goes from the lower limit of a and the upper limit of b. Right now we have each and everything with us, so now let's just substitute that into the formula and see what do we get. So we get the volume as v is equal to pi. The lower limit up here is 0 and the upper limit is going to be the square root of pi divided by 2, because he wants us to find out the shaded region's volume. And when we put the function f of x over here, so this becomes square root of x and sine of x squared, and I'll do the square of this thing and then I do dx, right? Now with all of this, what we get at the end is we get v volume is equal to pi integration of 0 pi divided by 2 with the square root and then x sine of x squared dx. Now what I can do is I can solve that using the integration by substitution. So I'll assume that u is equal to x squared and my du would become 2x dx, right? Now integration by substitution, so what I will be doing is I will be just multiply and divide that by a 2, right? So I end up getting this thing as 2x sine of x squared dx, right? What I'm doing over here is I'm just multiplying divide my x sine of x squared with the 2 and divide that by 2 so that the balance of the equation remains the same. However, my need is being fulfilled, because if I look into 2x dx, this can be written as du, and over here we have x squared, so that's sine of u, right? So I end up getting sine u du, and I have that as pi over 2, which is outside of the bracket, and then I have the x limits, which is 0 square root of pi divided by 2. Now guys, I have two options, and the options are that I just substitute the x limit, which in this case are x is equal to 0, and the second limit is square root of pi divided by 2, and find out the u equivalent, right, which is u is equal to 0, because u is equal to x squared, so I'll be just substituting that over there, and over here it becomes pi divided by 4, and I'll just place this value of x over here, right? So that's one of the thing that I can do. And there is one more thing that I can do is I'll just substitute that, I'll just integrate that as a u, and at the end whatever I get, I'll just rewrite that back in terms of x and then substitute the limits of x. So I'll do it this way, right? Like I'll just keep on using the limit of the x, and at the end I'll convert my function in terms of the x, right? So if I integrate sine of u, this will become the negative cosine of u and divided by 1, and the limit goes from 0 and square root of pi divided by a 2, and over outside of it I have pi divided by 2, and when I just substitute that u, so I'll get negative cosine x squared, and I'll just do one thing, I'll write negative outside of it and 0, and then I have square root of pi divided by a 2. Now what I can do over here is I can just substitute the value of the x limits, so I get negative pi over 2, and then I get cos squared cos of x squared, which in this case is square root of pi divided by 2 whole square, and then I do minus cos of 0 squared. So this is what I get, and I end up getting negative pi over 2. Now I have the cos pi over 4, and this will become cos of 0. Now cos of 0 is a 1, and if I look into cos pi by 4, this is given as 1 divided by a square root of 2, and then I have negative pi by 2 outside of it. Now what I will do is, I will just be multiplying all of them together and see if I get the desired result. So over here, I'll make the denominator as same, right? I will make the denominator as same, which looks like this. And outside of this, I'm actually multiplying negative pi over 2. So I end up getting negative pi over 2, and this is given as 1 minus square root of 2 divided by a square root of 2. So when I multiply all of this, I end up getting this result as pi. I'll keep that outside of it, and then I'll just multiply this negative sign inside of the bracket. So I end up getting square root of 2. This negative will become positive, and 1 was positive initially, so this will become negative, and in the denominator I have this thing. Now if I look into the actual question, this was not something that was desired, right? So I need to make something look happen, something to do with the equation that I found out, that it looks something like this, right? So the way I can get to this result is that if I multiply that with another square root of 2, right? So definitely it's gonna work. So if I do that, it is given as pi into square root of 2 times of square root of 2 minus a square root of 2. What I've done is I've just multiplied the square root of 2 in the numerator, and the very similar kind of thing I'll do in the denominator as well. So what I will end up getting is, I'll end up getting pi times of 2, because square root 2 is going to be 2, and 2 minus a square root of 2 divided by these two would give me the 2. So 2 times of 2 is a 4. So ultimately I end up getting this thing, and which was actually desired or asked in the question initially.